Okay, on one of your last problems of the day, you had a differential equation that looked something like this. dy dt equals 2y times 3 minus y. And then several parts of this problem, but the first part was to use separation of variables to find the general solution. So I'm going to go ahead and take you through the steps. There's several ways to go about it, and some of you got the right answer and may have done it differently. But I'm going to go ahead and just take you through what I think is the most efficient way to do it. And then you're going to have to do a few more like this. In the process, though, you're going to see some patterns develop, so you may not have to do every problem all the way out once you see the patterns. Okay, so first of all, for separation, I'm going to leave the 2 on the right side here. So I'll have 2 dt on the right, and on the left I'm going to have y times 3 minus y. So there's my separation step. We have to do our integration. The right side is going to be no problem, but the left side is going to require partial fractions. So let me come off to the side here. Let's figure out what our partial fractions are going to be. So we have a over y plus b over 3 minus y is going to be equal to 1 over that product y times 3 minus y. Okay, so in the process of getting the common denominator, I'd end up with a times 3 minus y plus b times y is equal to 1 if we just look at the numerators here. Okay, and then using heavy side, if we let y be 3, then I'll see that b is 1/3. And if we let y be 0, we see that a is 1/3. So that's kind of interesting. They both end up being the same. But anyway, come back over here. Decomposing that fraction, we now have, well, 1/3 is common to both, so I can pull the 1/3 out front. And I have 1 over y plus 1 over 3 minus y dy. And now I'm ready to integrate, and I'll go ahead and finish this right side right now. That's going to be 2t plus a constant. And right here is where some of you made your mistake when you did your integration. The first one, no problem, is going to be natural log absolute value of y. And this one, if you do a quick little mental u sub, okay, u is 3 minus y, notice that the du would be negative 1 dy. And so you'd have to fudge in a negative, and that makes this a minus natural log of 3 minus y. Okay, now, solving for y. Several ways to do it. Take a look at how I do it here. Okay, multiply both sides by 3. So we're going to get 6t plus still a constant. And now I have 2 ln's. And let me keep them written like this for a second here. Okay, now this is a subtle point, and I'm doing this because I can see what the calculation's about to go. I'm going to combine these ln's in a second, but I would rather it be 3 minus y over y than y over 3 minus y. So I'm going to fix that by multiplying both sides by negative 1. Okay, so over here you get the natural log of 3 minus y, absolute value, minus the natural log of y, equals, I still have that constant, okay, but now I have minus 6t. Okay, so here's why we did that. We want this natural log to be 3 minus y over y. Okay, c minus 6t, and now we're going to exponentiate both sides. So raise both sides, or make both sides the exponent of e. Here you're going to have absolute value 3 minus y over y. Okay, here you're going to have, if I split this up as e to the c times e to the negative 6t, e to the c is still a constant. Okay, so I can still call this a constant. And this is going to be a plus or minus, but that will be all figured out once I figure out what the constant is. So I'll drop the bars. We'll come back to them once we have some initial data. Okay, but I have constant e to the negative 6t. And now here's why I wanted this fraction in this form. I can split this fraction. 3 over y minus y over y, which is 1. And now I can solve this pretty quickly here in a couple more steps. Okay, so we're going to add 1 to both sides. And then we're going to flip both sides. So I'll have 1 plus c e to the negative 6t is equal to what? 3 over y. And then we flip both sides, multiply both sides by 3, and we're done. Okay, so we'll have finally y equals 3 over 1 plus c e to the negative 6t. C would depend on some initial data. Okay, so that's pretty short. What I want you to do for your entrance ticket is a couple examples of the same kind of process. If you see a pattern, great. But I want the solutions to these differential equations. Okay, so let's go 5y times 7 minus y equals dy dt. dy dt equals 3y times 11 minus y, and dy dt equals ky, k is a constant, times m minus y. Okay, when we come to class next, we'll work with this differential equation and do some things with it that have some pretty cool meanings. But I want you to get familiar with what the solutions to these differential equations look like first. Please email me 2 questions that you had on the video, and we'll see you next week.